Today's session is about DevOps and introduction to DevOps, what DevOps is, what DevOps is not, and uh, discussing different aspects of DevOps, how it can be implemented in an organization, and what are really the tools and technologies involved in it, and what kind of mindset you need to implement DevOps across your organization. This image here in the first slide explains a lot about DevOps. It if you see it, it looks like a software development life cycle. You have already seen a lot of them, right? One of them is the waterfall model, and then the next one is the agile. Basically, let's discuss the software development lifecycle and build on top of that how DevOps comes into picture. In the waterfall model, what happens is there will be a product team which involves a director, a project manager, a product manager, and different development and operations teams, a QA team. So all those teams work together and to build a market ready product for the client. So the in the waterfall model, there will be a requirement gathering phase, a planning phase, a design phase, and then the dev and QA phase will start, and finally the code will move to the prod. So the problem with the waterfall model is that you need to complete each phase before starting the next phase, and in that process the time to market is can take very long time, like it can be from a month to several months. So that's not an effective way of delivering a product, right? So then came the agile model. So agile, you all know, right? If you are a developer, then you follow the Scrum and Kanban. Agile is very fast. It gives you opportunity to release code or features in a very fast manner. But again, in agile method, you can divide each feature development into sprints of 2 to 4 weeks, and you can just complete it. And feature by feature, you can keep developing, which will give you more space to release it frequently. It will give more reliability, and you can fix everything much faster than the waterfall model. So these are the software development life cycles commonly used in industry. So let's move on to the next slide. So if the question is, if these models are already there, why do we need another method which is called DevOps? And is DevOps really only a software development life cycle, or what it is? We will discuss that as well, and we will discuss various tools as well as DevOps, how the CI/CD and DevOps architecture looks in the cloud. So here is the big question, right? So what is DevOps? So if you go through the internet and various sites or various DevOps conferences, they will tell DevOps is not the tools. DevOps is not a standard or a kind of a product, or if even it is not a job title, though there are DevOps engineer jobs out there, but actually it is not a job title. What DevOps really is, it's a culture you need to inculcate in your organization between teams to collaborate, communicate with each other, to uh, to to work together so that you can achieve great products in the end. And DevOps, as mentioned here, it is a bottom up approach. What does bottom up means? It is a movement or a practice or a culture created by the people who practice practice all the development and operations activities. So what happened was, if you go back in time, so in 2007, there's a person called Patrick DeBoy who worked on both side of the product development. So both side of the product team, dev and ops, and he got really frustrated with the conflict and uh, the problems that and the friction that is between the dev and ops teams. So in 2008, he met Andrew Sheffer, and they begin brainstorming uh, this problem, which was causing very delay in software development and the product release. So in 2009, it went on. So they attended a DevOps conference, so where Flickr uh, presented that they deploy 10 plus updates in one day, and that was a very surprising thing for them. And after that, a lot of papers uh, get presented, and lot of DevOps conferences, DevOps days happened throughout the world. And it was basically the evangelist phase where people so any before any technology starts, you need to create a buzz. Before any culture starts, you need to create a buzz, and once it percolates through all the organizations and all the people who work in that domain, after that it becomes stable. So DevOps has passed the test of time, and now you can see it everywhere. And all the organization, uh, they have to adapt the DevOps culture, otherwise they will be left behind. So you can see that in case of like Amazon and Walmart. So how far Amazon has gone. Even Amazon deploys software per second, right? Per second they have a new update. So this is the a brief history on DevOps. So let's come back to the basic question. Like we answered that question as DevOps is a culture. So what kind of mindset you need, and why this culture needed to be developed? So DevOps culture is all about collaboration, communication, and how to integrate the teams, and how to how to advertise the automation, how to implement automation in all the processes. So there should not be any manual intervention, because manual intervention means lengthy processes and lengthy and slow time to market, so you cannot deploy software that much faster. So let's see what is the problem of the development team and understand it, and what is the problem of the ops team. So the dev team always focuses on the feature, how fast they can deliver a feature. That means they always focuses on speed. And ops team always focuses on the reliability, the stability of the code that is in the server or anywhere in the cloud deployed. So you can see in the first image that their goals are really opposing to each other. So they are not in alignment, and even dev don't know what ops how ops works and vice versa. So with implementing DevOps in your organization, you can bring a alignment and a culture of collaboration between the dev and ops team, and then their goal will be aligned, and they will care for each other's goal. So like the dev will care for the stability in the prod environment, and the ops will understand that okay, dev need to deploy or dev need to make the updates in a faster pace. So get back to our traditional story of the dev and ops. So you can see here, like there is a wall between the dev team, QA team, and ops team. So it's basically uh, there is no collaboration between those teams. There is no proper communication between those teams. If you take the traditional silos, so what happens in the traditional silo is there will be requirement gathering, and the dev team will start working on it after the design phase is completed, and then they will develop their software or their write their code on their machine, and they will do the unit tests and everything, and mm, they will just throw it to the QA team over the wall, and the QA team will do all the testing, and the dev and QA will play back and forth with that code. And once everything passes in their environment, they will pass it to the ops team to deploy it in production. So what is the problem here? So actually, there is no proper collaboration between dev and ops. So they are kind of a black box to each other. There is no visibility of what ops team is doing to the dev team, and there is no visibility vice versa. So this leads to conflict and trust problems. So the teams will not trust each other, and there will be friction. So the next problem it can give is, so they have different priorities, right? The dev team cares about speed of deployment and speed of change, but the ops team needs stability so that the production environment don't break. So there also you can see a friction. And even if they want to work together, the organization or the management measure their performance by like the speed and the stability. So so this is the summary of working of downsides of working in silos if you don't collaborate between each other. So like we discussed, it will trigger finger pointing, blame game, and it will cause friction, which is not good for a product team to build a great product. So there will be very slow time to market, which will again cause business loss. Directly it will affect the business. And then you need to have automation in your process, otherwise it will again cause the same issues. Like there will be no consistency, there will be a delay in product delivery and deployment. And and again in this you don't have a feedback loop, right? When something breaks, it will take a lot of time and energy to identify that thing and then fix it. So these are the problems we need to think about, uh, and then like DevOps comes into picture to solve these issues. So in a DevOps team, what happens is whatever team uh, uh, is involved in the product development all should collaborate, communicate with each other. So either be it a product manager or project manager, either be it like a developer dev team or a QA team or a ops team, they all need to work together to make the product a success. So um, so again, you see here that wall collapses and they work together. And automation plays a main part in DevOps. So you need to automate each and every step so that it will not depend on anything manual. So even if automation is there, some organization do a manual deployment that is called continuous delivery, and some organization make it completely end-to-end automated. And then if something breaks, we have a feedback loop because we will monitor it continuously, and that will give us a very good time to respond quickly and fix everything. And also DevOps team does very frequent deployment, which means you don't need to fix a huge chunk of code. It's like you need to be focused on the small chunks, and that is really easy. And if something goes wrong, you can roll back easily to the previous state. So what went right here after applying DevOps? So they work together, then they are now aware of each other's challenges, each other's difficulty, and the flow goes really smooth. Even if some problem comes, even if some production issue comes, you can identify, because there is a feedback loop called continuous monitoring and all the log analysis, and then you can close that gap, right? You can easily fix that issue, and it will make both dev and ops team really happier, and a happy team develops really great product, right? So let's move on. So why we need to do DevOps? Why we need to adapt to the DevOps principle and philosophy or culture in our organization? So as we discussed, right, it will lead to happier teams. There will be no finger pointing, and there will be. It is always good to discuss the problem, uh, because if you keep it in silos, it will always increase, and it won't help. And also happier customers, because if you delivers the features in more frequent way, customer will always be happy with less errors. So let's say you are developing something for a food delivery company or some e-commerce company, and that applications really need very fast feature deployments. Otherwise you will be behind your competitors, right? So this is what DevOps brings into the table. Also, if you see, DevOps can increase the speed and the reliability, uh, how product is going to be delivered. So this is uh, I have got this screenshot from the payscale.com about the state of DevOps jobs and the salary package they are getting currently in India. So you can see, right, DevOps engineers are in huge demand, and they are getting good pay. So this is the I will say this is the right time to get into DevOps. But again, DevOps is not a buzz anymore. It is already used in organizations, and DevOps, uh, the roles and responsibilities. We need to check the roles and responsibilities to apply for those roles, and how we will identify that roles. I will discuss it in later slides. So we discussed everything process related, how DevOps helps organizations, how it helps teams to build great products, how it removes the barrier between uh, all the uh, all the different teams, be it dev, be it QA, be it security team, be it ops team. So now let's discuss what are the tools which can help us be success in our DevOps journey. So DevOps process is basically what we saw in that infinite diagram, right? It is plan, plan, and then the dev part, and then the continuous build, continuous integration, continuous delivery and deployment, continuous monitoring, so that we will have a good feedback loop, and a lot of other tools are involved in this process. So tools are really needed to automate the DevOps process and to be successful in the DevOps journey. So here, what you see in the slide, it's continuous build. So when the developers develop their code, they uh, they need to produce a stable build, and these tools can help to compile that code, free it from any lint, and after the unit testing is done, all those things can be automated through these tools. So these tools are like Apache, Ant, Maven. Those are for mainly Java, and you can see SBT for Scala as well. There are a lot of other build automation tools in the market. So let's go to the next phase where there is a need to do continuous integration. So what is continuous integration? So when so let's say we have a dev team and there are a lot of developers pushing their code and committing their code to the repository continuously. And in that case, if we don't do continuous integration and we just wait for the all the push to be committed and then build our code, we may see a lot of failures. So continuous integration is meant to do a build per push per commit. So you know, in each commit there will be a build produced, so that you will know if that build passes all the tests or not. And if that build fails, then you can go back and the developer can go back and fix everything and then run a build again. So uh, this is a good way of making sure that you are writing writing code and the build is successful. Good code and the build is successful, so that you don't have to troubleshoot a large chunk of things at once. So there are very good continuous integration tools in market. Jenkins, Circle CIM, Bamboo. I found these three like most popular, but there are a lot of tools out there. Even some AWS related and Azure related tools are there. So let's go to the next phase, which is infrastructure as a code and configuration management. So what is infrastructure as code? So you know, when people were installing servers in data center, how many days it used to take, and then the cloud solution came, which will spin up a server or a Kubernetes cluster or the infrastructure in minutes. But again, if you have a large infrastructure, then maintaining it manually is very unreliable. Also, it is very much it can disrupt things in the environment. So their infrastructure as code comes in and saves the day. So we have a lot of infrastructure as a code tools. So Terraform is one of the popular tool. You have AWS CloudFormation as well. So these are infrastructure orchestration tool which can spin up or provision or destroy or change a lot of things in the environment, in the infrastructure, be it Kubernetes cluster, be it EC2 instances, or be it any other container service. And then the configuration management tools, what they do is, let's say you want to change a configuration in hundreds of servers, or you want to even Ansible and Puppet, these are configuration management tools, but again they can also be used as a provisioning tool. And Ansible, Chef, and Terraform are really popular tools to learn as a DevOps professional or as a site reliability engineer. So the next thing is container orchestration. So this is the time of containers, right? Everywhere, all the apps are mostly deployed in container environment. So what is a container? So in the data center days, I will say people are deploying their codes and application uh, in the servers, which are like on the physical server. There will be a OS installed, and then there will be some virtualized platform like VMware, and then Then on top of that, there will be a lot of guest operating systems, and there your application will reside. But what is the difference between a container and a VM is container don't need any separate OS. So container only needs the libraries and binaries that is required for your service to run inside the container. So container is very lightweight, which will again reduce our task to create that heavy load servers. So when container came into picture, then there was a need for the container orchestration tool. So if you have, let's say, thousands to millions of containers running in your environment, you can't manage it with manual intervention or some kind of script. So in that, Kubernetes and Red Hat OpenShift comes into help. Red Hat OpenShift is also built on top of Kubernetes. So Kubernetes is actually developed by Google and again donated to the Linux Foundation. So Kubernetes, what it does is it has pods inside which you will provision your containers, you will deploy your application, you can scale up, and then it will manage the whole entire life cycle. So hope this one is clear, and then let's move to the next part where we will look at continuous monitoring. So after all this process of developing code and then testing it, creating a build, and then deploying it to the production with all the containerized environment in your cloud environment, be it Azure, AWS, or Google Cloud, you need some feedback loop so that you will identify if any problem is there and fix it as soon as possible to eliminate downtime. So that's where monitoring is needed. So there are two kinds of monitoring: infrastructure monitoring and application performance monitoring. So uh, these are the tools which can perform monitoring. So Prometheus is a very popular tool where you can monitor your applications, and then you can generate some alert, pass it to ServiceNow, and then it will generate um, the tickets. And then there is Elastic Stack and Splunk, where you can gather the logs of your application, do some analysis. You can get alerting on top of that as well, and you can look for a lot of insights as well. Let's move on. And so SCM, I think whoever is a developer, they are for sure using Git. Git is a source code management tool, which tracks your changes, and which allows you to create repositories. So if you have a project, that whole folder you can initialize with Git, and then you can track. So it will help in merge conflicts as well. All those things, all those concepts are there. And then there is GitHub, GitLab, and Bitbucket, these remote repositories, which will host that Git repository remotely for a team, so that entire team can contribute to that project or product in that repository. So these are all open source tools, and some of them are also licensed, like ServiceNow and Splunk. But most of these I have highlighted, those are open source. Here Jenkins is open source, and here all these are open source, but Circle CI and Bamboo are not. So there are we have two kinds of things in cloud as well. So either you can spin up your servers, install open source softwares there, and you can build your project end to end. The other method is building everything on cloud with cloud services. So let's look at this architecture provided by AWS. This is a CI/CD architecture where all the all the things we discussed in the previous sections are built with services that are provided by AWS. So here you can see there is a storage service called S3, and there is this code build cloud formation which is related to Terraform. AWS code build is there, and then there is an event driven serverless service called AWS Lambda. So this architecture, what it shows is the entire CI/CD process. So here, if you see, developers develop their code, and then there will be a development account, and there will be a production account. So all the testing all the testing, so like code commit and then notifications, and then based on that notification events, some lambda script you need to trigger, and then after that you can use AWS code pipeline where you can build it and even build the infrastructure you like and deploy it to the development environment to do various kind of testing. And then there will be a production pipeline where you can again build the code and build the infrastructure uh, based on cloud formation templates, and again write some lambda script using Python or JavaScript, and you can move your chain set to the production either through manual process or through automated process. So this is how it looks in AWS. So we can also discuss about the two other major cloud providers. So this is a simple CI/CD, how it looks in Azure. So in Azure, we use like Azure DevOps pipelines, or people can also use GitOps, because like GitHub is now acquired by Microsoft, right? So GitOps is another kind of CI/CD you can do, and that is like in all the cloud you can do that. So here uh, from developers it goes to Azure repos, and then there will be pipeline created, and then it will be deployed to test environments, and then to the prod environments, and then there will be monitoring and the feedback loop. This is a very simple CI/CD, and there are other environments also will be involved in it, like you can deploy it to a Kubernetes environment as well. So AKS is the service, Azure Kubernetes service. So this is how it looks in GCP. So basically the concept is same. You can use open source or the cloud services. The cloud services are also built on top of open source tools only. So this also shows the same process, right? When developers commit their code, then it will be built, and then that container image will be sent to Spinnaker, and it will be deployed to the Google Kubernetes engine, and then users can access that through this load balancer using GCE or GKE. Okay, so this is the CI/CD architecture in Google Cloud. So now where we are like we know what is the architecture in a web development environment, what are the tools we need to use, and what is the process, end-to-end process of DevOps. And again, always keep in mind that these tools and these architectures aren't DevOps. They add to the success of DevOps. DevOps, you need to always remember that it is a culture, it is a practice that you need to inculcate in your organization, inculcate in your teams. Because even if you have all these tools and you are doing some work, but you don't have the proper communication, collaboration, and you don't have a automation mindset to automate all the manual things, then that team will fail, because fail to implement DevOps. So that we need to keep in mind. And again, what are the roles and responsibilities of a DevOps? You can say DevOps engineer or a site reliability engineer. So these are the job posts you will see on in various ways, like DevOps engineers, SRE, site reliability, build and release engineer, DevSecOps engineer, and automation engineer. So don't confuse that. If it is not DevOps engineer, then it is not DevOps role. It's not like that, because we already discussed what is DevOps. And the real responsibility of a uh, DevOps team or a DevOps consultant is really to implement those culture and practices in the team or in the organization. So you can look for these all these roles when searching for a DevOps engineer job.